Hey Flux Capacitor, my name is Matt Bowring, and for the past few years I've been leading development for MATLAB's quantum computing library. I'm currently a graduate student at Purdue University studying electrical and computer engineering. My startup is Gigabug Computer, and we're developing novel printed circuit boards to solve optimization and machine learning problems using an unconventional architecture based on nonlinear coupled oscillators. So this is fundamentally an analog type of computer. And what's funny is, analog computing actually came before all the modern digital computing that we have now. And as people try and push transistors smaller and smaller and smaller, we're kind of seeing this leveling off in performance basically per dollar. And so there's been a lot of research looking at, hey, what are some alternative computing frameworks that we can use to kind of push past this barrier. And so what's old is new again, and so people are looking back on analog computing and saying, what kind of problems are best suited for this analog paradigm? And so my circuit that I'll talk about here in a second, I actually have a prototype to show you, is based on, for solving combinatorial optimization problems. It can actually be extended to more general machine learning problems too. And the idea is that this can be orders of magnitude more energy efficient because you're relying on the inherent dynamics of the system to solve your problem. And this circuit is actually designed where the dynamics, if you think about this combinatorial problem, and we have many different possible solutions that we have to pick from, by encoding this problem onto the device, we basically create an energy potential where the dynamics of the circuit, these analog signals actually follow the energy gradient, okay, and they come into a local minima. And then by reading out the state of the system, you basically get your solution. Now I'll talk about, show you the circuit and more about how this works. And so my idea, my company that I want to develop is, this is still kind of an unconventional architecture. There are still open problems, and how do you map, how can you solve different problems on these computers? It's people are still trying to really figure this out. And so what I want to do is release, basically my circuit right here. I have a bunch of prototypes developed. Is, I want to put out a dev kit and say, hey, you can buy this printed circuit board, and I want to put out an open source software framework that lets people get their hands on it and start programming with it, and figure out, how can we map different kind of problems to the circuit? How can we develop more algorithmic training methods for this kind of technology? So I'm really excited about it. And so let me actually show you how the circuit works. Okay, so here's my circuit. I'm going to actually remove this top board. There are two pieces here. Okay, so this board contains the analog signals, and this board contains a digital programming array. So there's a bunch of digital potentiometers here that lets me create a programmable resistor. And what this allows me to do is create delays between all the oscillators. Okay, so if we're solving this binary combinatorial problem, effectively, this oscillator board is going to have these waveforms. And if these waveforms are aligned, basically corresponds to a 0, and if these waveforms are misaligned, that's going to correspond to a 1. And so by creating this, by programming these resistors, that effectively creates this energy potential that I talked about. And these phases are going to naturally follow this energy gradient and effectively align themselves to solutions of the input problem. It's actually really quite amazing how this works out. And so this here is just a generic microcontroller, and so I can plug this thing into my laptop with a basic USB-C cable, and that's going to allow me to easily program this device. So this is what I propose for my dev kit that I want to sell, and open up a software framework that makes it really easy to program this thing, so people can get their hands and start playing with it. So what I just showed was a prototype circuit. Going forward in the next 4 months with the funds, I want to develop my next generation that's going to scale up this architecture. Additionally, I'll need to hire or contract engineers to help me write low-level control firmware code, as well as develop high-level APIs for users to more easily program and use the circuit. Additionally, I'm going to develop my website to provide documentation, as well as a portal to easily purchase the dev kit. You can read more on gigabug.org. I'll put the link in the description, and thank you Flux Capacitor for the consideration.